So it will be recording right here. So you guys could have this later on Google Classroom. Feel free to stop me if you guys have any questions. I'm not going to explain all the questions here. I'm only going to go through a couple, I guess. Or maybe we'll do the even ones. Then you guys could go back and do the odd ones. So right here on the first part, it says find the indicated term of each arithmetic sequence. So they want you to find the indicated term of each arithmetic sequence. So what does a sub 19 mean? That's a notation for the 19th term. So they want you to find the 19th number for this sequence, okay? It is arithmetic. So if we wanted to state everything that we can about an arithmetic sequence, you're going to start by saying that that first number is the notation a sub 1. And we also could find the common difference d by simply taking 48 and subtracting the previous one from it, or taking 32 and subtracting the previous one from it, okay? So if you do that, 48 take away 32, or 32 take away 16, you will get that common difference of 16. Again, you don't just want to think, oh, what's the difference between 16 and 32? You want to take 32 and then subtract 16 from it. So 32 take away 16, use a calculator if you need to. You get the common difference, D being positive 16. So now that you know your A sub, now that you know that there's 19 numbers in your list, all right, maybe that's a good thing to write down as well, that there are 19 numbers. That means that the number of terms n equals 19 because there's 19 numbers on your list. After all, what are you used to seeing here? A sub n. And what is n really? N is 19. So we just wrote that down as well. So by looking at this information they give us, we have identified three very important things: the n, the a sub 1, and the common difference d. Okay. So now we got to go back and realize which one are we using, the a sub nth rule, this formula, or the summation for an arithmetic series, which would be this guy, right? It all depends where you could plug in all three of these values. So could we plug in a 19 into this first one? Yeah, because there's an n right there. We could also plug in a 19 right here to this n. But the a sub 1, we could plug it in right there, and we could also plug it in right here. So far, both of them are good. But where could you plug in that common difference of 16? Not here, only here. So just by getting the information and seeing where do all three fit, right? They all fit on this one. So that's why we're going to use the a sub nth rule on this one. Regardless of what they're asking for, that's the only one you could use right now, okay? So let's start by writing the a sub nth rule. It's a sub n, and in this case, it's a sub 19 equals a sub 1, which is 16, and then it's plus parenthesis n minus 1. Now we know that n is 19 minus 1 times that common difference d, which is 16. Now, again, if you're wondering where the heck did he get this, this is the a sub nth rule up here, right? A sub 1, 16, n, we said it was 19, common difference d was 16. So now we could just get this actual answer by doing the math, and you could do this math on a calculator if you want, and that will be your a sub 19th term. So if you do this work on a calculator, the 16 plus, that's really a 18 times 16. If you do that work on a calculator, it will give you the answer 304. So what we have here is a sub 19 is really 304. Okay. Now, if we go back to the instructions and it says find the indicated term, which I think that's what this was, find the 19th term, then that's what that would be it. The 19th term on this list would be 304. If they said go back and find the summation, if you had plus signs, oh no, this would be infinite because it keeps going forever. But anyways, yeah, the instructions here say find the indicated term, find the a sub 19th term, and a sub 19 is 304. Let's move on to question number 4. What do the instructions say for question number 4? It says write an equation for the nth term of each arithmetic sequence. So they want the equation that produces the list, right? So ultimately, you want to find the a sub nth rule, but we may have to use a summation depending on the information that they give us. So let's see what information they give us. A sub 1, the first term is negative 416. What is the common difference? Well, let's take a number like negative 137 and take away 230 from it. So a negative 137, take away a negative 230 from it. So that's really a plus 230. So negative 137 plus 230 on a calculator is 93. So we have equals 93. So the common difference is 93. So the D is 93. That's your common difference. So we have our a sub 1 term. We have our common difference. That's what we have so far. I mean, yeah, we have the a sub 2 term, a sub 3, a sub 4. But when you think about the two formulas that we know, they want the a sub nth rule. And all you need for the a sub nth rule is your first number and your common difference, right? They're not even asking for the summation, so you're not using this one. So let's plug in our a sub 1, which is negative 416, and then plus parenthesis n minus 1 times that common difference of 93. By the way, I didn't verify that the other ones are 93, but you could do it on a calculator. Negative 230 minus a negative 323, that will give you 93. Or on a calculator, negative 323 minus a negative 416, that will give you 93. Why did I not check that it was common? Because on the instructions, it says that it's an arithmetic sequence. So if they tell you it's arithmetic, that means that it does have a common difference. That's why I didn't have to go back and check that. Anyway, now that we have the a sub 1 and the common difference D right there, we're going to be able to write the a sub nth rule. All you got to do is some math, and you could use a calculator. 93 times n is 93n minus 93, because 93 times 1 is also 93 with a minus sign. Bring down the plus, minus 416. And now with the calculator, minus 416 minus 93, be on the safe side, that's going to be a negative 509. So what we really have here is positive 93n minus 509, or plus negative 509. So this is the a sub nth rule, and that's what they're asking for, right? Now, let's say you were kind of hesitant. You're like, man, I probably made a mistake or something. You could always plug in the number 1 right there. 93 times 1 is 93, and 93 minus 509. If you plug in a 1 right there, 93 minus 509, it really is negative 416. So that's how you can verify that you did it right. Or you could plug in like the number 3, and with the calculator, go 93 times 3, and then minus 509. I just did that on a calculator. My answer was negative 230. And yeah, if I plug in a 3, I got out a negative 230. That is the third term right there. So you could be 100% confident that you did it right by simply plugging in a 1, making sure that you get out that first one, plugging in a 2, making sure you get out that second one. Or maybe you're already confident, so you don't need to do that. That's just a way of double checking. Question number 6 is interesting because it's the first time that like they ask you to fill in these missing numbers. This is an arithmetic sequence, and you want to find the missing numbers in between the first number 235 and the last number 32. So far the two formulas that we know are the a sub nth rule, a sub nth rule, and also the summation formula for an arithmetic series. So the question is, which one do we use? It's the same concept as always. You have your two formulas, and you got to realize what they give you and see where you could plug it in, right? So they give us a first term and they give us a last term. So they give us an a sub 1. Maybe I should write it up here. A sub 1. What is a sub 1? Is 235. That's your first term. They give you your last term, a sub n, which is 32. Okay. So those are the two things that we know so far. Is there anything else that we know? Anybody? Any ideas? Perfect. Yes, there's going to be 8 numbers. So 1, 2, 3, 4, 5, 6, 7, 8. So we know how many numbers there are. We're going to call that n equals 8. Okay. So let's think about these 3 things that we have. Okay. We have a sub 1, we have a sub n, and we have n equals 8. Now to start, when do we use this guy? When we're trying to find what? The S, which is summation, which is a series, which is addition. Is this an addition problem? Heck no. This is just a list of numbers. So we're that just by knowing that, you got to start thinking, well, I better use the a sub nth rule. Okay. So what would I need to know in order to get this next number? The difference, the common difference. So like if the common difference was minus 10 or negative 10, you would say 235 minus 10 would be 225, minus 10 would be 215, and you keep going until you get to 32. But the thing is, we don't know the common difference. But again, we're not adding them up, so we better stick with this guy. So let's plug in what we know, and let's see what we could solve. Let's see what it looks like after we plug in our values. So right here it says a sub 1. We're going to plug in the 235. It's going to say plus, and n minus 1, what is n? We just said n is 8. Minus 1 is still there, minus 1. Times that common difference, which we don't know. Okay. So this all equals a sub n, right? Now, the problem is we need this to be a number in order for us to be able to solve for d. Do we know what this number is? It's 32. That's right. A sub n is that last number. First number, last number. So it's 32. So we're going to plug in that 32 as well. So now we have an equation that we could solve for. Let's actually do that. We're going to have 235 plus parentheses 7 times d equals 32. Okay, and then from there you solve it by subtracting 235 and subtracting 235. And we're going to have, yep, we get minus 203 and negative 203. So I'm going to rewrite my equation up here. Negative 203 equals 7d. Not 7d, but 7 times d, right? And you want to solve for d. So you divide by 7, and on the calculator, negative 203 divided by 7, that equals negative 29. So negative 29 equals d equals negative 29. Now that we have d and we have a sub 1, we could technically write our a sub nth rule, and then you could plug in like the number 3 if you wanted to find the third one, plug in the number 5 if you wanted to find the fifth one, or you could just be like, well, I already know what the common difference is. If I have my first number, I'll be able to find the next number. So it's simply 235 take away 29 to get to the next number. And I'm doing this on the calculator so I don't make mistakes. That's 206. So we have a 206 right there. And then take away 29 again. That's 177. Then take away 29 again. That's 148. Again, all in the calculator. Take away 29 again. That's 119. Take away 29 again. That's 90. Wait, did I mess up? Take away 29 again. That's 61. And take away 29 again. Yep, I get that last number 32. So I know I didn't mess up, right? It's okay to feel that you messed up, but keep working it through and you'll see it. Again, you could have, once you know the a sub 1 and once you know your common difference d, you could have plugged them all into the a sub nth rule, your a sub 1 there, your common difference d, distributed that value, written it in the form of like something x plus or something n plus something, and then you could find the first term by plugging in a 1, second term by plugging in a 2, and so on and so on. But if it's just asking you for a very small amount of numbers, you could just take that number and subtract 29, and so on and so on. Okay, let's move on to the next one, number 8. So number 8, everybody jot that, or let's all work this out. We have our two formulas. What could we conclude from this? What information could we pull from this? We know a sub 1 is 5. We know a sub n is 32. Anything else we could find just by looking at this series? Yeah, common difference. Okay. And the common difference is 3. 14 take away 11 is 3. 8 take away 5 is 3. 11 take away 8 is 3. So yes, the common difference is 3. Okay. So with that information, we have an a sub 1 that could go here, but it could also go over here, especially because we have addition, right? We actually do want to add it up. So we actually do want to ultimately use this. So could we plug in a sub 1 right there? Yes. Could we plug in a sub n right there? Yes. We're missing the n. That's the problem, right? We have a d, and there is nowhere to plug in d right here. So just based off of the information that you know, a sub 1, a sub n, and d, where could you plug in all of those three values right here? A sub 1, uh, a sub n, and d. So we're going to use this first one because that's the only place that we could plug in all the information that we pulled from this series. So a sub n is really 32 equals a sub 1 is really 5 plus parenthesis n minus 1. I don't know how many numbers there are in the list, so I'm going to leave it as n. And then times that common difference, 3. So now all we have to do is actually solve for n. And once I have n, I'll know what number to plug in right here to actually use the summation formula, because that's what I have here. I have a summation, plus, 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 right? So let's solve for n. You got to get n out of those parentheses. The only way to get rid of those parentheses is to distribute. 3 times n is 3n. 3 times -1 is -3. Bring down the plus, the 5. You still have the equal sign. You still have the 32. But you could now combine the 5 minus 3. That's a positive 2. And put the 3n in front. So you really have 32 equals 3n plus 2. So I'm going to start getting n by itself by subtracting 2. Subtracting 2. I end up with 30 equals 3n. Finally, I'm going to divide by 3, divide by 3. So that tells me that 10 equals n, or better said, n equals 10. So now we do have everything that we need for the summation formula. We have n being 10. We're going to plug in that 10 right there. I still don't know how many terms I have, so it's still s sub n. The summation of all these numbers is going to be 10 times a fraction. And up in that fraction, you're going to be adding the first number with the last number. First number is 5, last number is 32. And we're still dividing that summation by 2. So 5 plus 32 is 37. So what I really have here is 10 times 37 over 2. Now, I know that 37 is not divisible by 2, but 10 is. So if I don't want to go to the calculator yet, I mean, you could go to the calculator and just do 37 divided by 2 and then times 10. Or you could just say 10 divided by 2 is 5, and then 5 times 37. You could do that on the calculator or on paper. That'll be 185. So the S sub n equals 185. So we just found the summation of, I don't even know how many numbers those are, but I do know, actually, no, we do know how many numbers those are. We found out that n was 10. So that's technically, for a better notation, it would be S sub 10. The summation of those 10 numbers, you don't even see all 10 of them, but the summation of those 10 numbers is 185. Move on to this next one. Again, I'm doing the even ones on this video. So wait a minute, what happened to my other one? So number 10 is a series, not a sequence. What's a series? It's simply a list of numbers that you're adding, and in this case, it's an arithmetic series. So let's just list off the things that we could identify already. Everybody knows that a sub 1 is the first term, which happens to be -2. We also know the last term, which happens to be -20, okay? And of course, we want to add all of these numbers up. So if you think about the two formulas that you know, the S sub n or the A sub n, or I should have probably put the A sub n first and S sub n second, um, which one are we going to be using? Well, is there any other information that I could pull out of this series? Common difference. Thank you so much for stating that. And the common difference could be found by simply doing -8, take away a -5. So that's really a -8 plus 5, which would be a -3, or -5 minus a -2, which is really a -5 plus 2, which is still -3. Okay, so the common difference is -3. So far we have three things. We have a sub 1, we have a sub n, you have the first number, you have the last number, and you have that common difference of -3. Okay. Um, so the question is, which one are we going to use? We are trying to find the summation. So obviously, you're going to try to use a summation formula. Let's see if we have enough information to do so. Well, when you plug in a sub 1, it would go right here. So you have your first number, and I might as well start writing this out, even though I might not be able to finish it off, all right? The first number is -2, and we're going to add it with the last number, which is -20. And it's still going to be divided by 2. Maybe I should have put that -20 in blue, make it more color coordinated. All right, and we do need the n right here. N is the number of terms. Do I know the number of terms? 1, 2, 3, 4. Is there 4 terms? No, there's a bunch of terms missing. We don't know. So we are missing this n value right here. So we can't really find the summation without that n value. So we're kind of stuck right there. So, or another way of thinking of this, even before plugging things into here, another way of thinking of it is you have a sub 1, you have the common difference, you have a sub n. Where could you plug in all 3 of these guys? Where could you plug in all 3 of these guys just into this? Because you have the a sub 1, you have the common difference, and you have the a sub n over here. So this is the one you're going to start with because you could plug in all those 3 bits of information into the a sub nth rule. So even if you did try to plug it into the s sub n the way I did, you're going to realize, oh, I still need this number to find the actual summation, right? So anyways, we're going to go a sub n. What is a sub n really? Well, we know a sub n is the last number, which happens to be negative 20. And then we have a sub 1, which happens to be negative 2. And then we have plus parenthesis n minus 1. We don't know n. We don't know how many numbers are on the list, so we're just going to leave it as n minus 1. Times that common difference. The common difference is negative 3. Okay, so because we were able to plug in all 3 bits of information into a sub n, and we have only one variable left, and it's an equation, we could solve for that variable and figure out what that n is. And once we figure out what that n is, then we're going to be able to plug in that value right here and actually be able to find the summation of the whole thing up here. So again, we are going to distribute negative 3 times n is negative 3n. Negative 3 times negative 1 is a positive 3. Bring down the plus the negative 2. And out of those 3 terms, you can't combine the negative 3n with anything. So I'm just going to rewrite it, negative 3n. And then I'm going to combine the minus 2 and the plus 3, and that's going to be a positive 1. Now we still have the minus 20 over here that comes down on the left side of the equal sign. And now we just need to solve for n. So let's get rid of the plus 1 by subtracting 1. Subtracting 1, we're going to end up with a negative 21 equals negative 3n. Now that negative 3n really is saying negative 3 times n. So you want to get rid of that multiplication of negative 3, do the opposite of multiplying, which is dividing. So you divide both sides by negative 3, and you will end up with positive 7 equals n equals positive 7. So it's a reoccurring theme on this section. You get your formulas and you look at the information given to you and you plug in all that information wherever you can and you go from there. So because we were able to plug in all these 3 bits of information in this guy, we were able to solve for n, and now we could actually plug in that n value of 7 and figure out what the summation is going to be. So we have the summation of how many numbers? We actually have 7 numbers on this list. How do I know that? Because we just solved for n. So the summation of the 7 numbers will equal the n being 7 times the negative 2 plus negative 20, and it's divided by 2. So what we really have is negative 22 divided by 2 inside of the parentheses times the 7 on the outside. So the summation of the 7 numbers is going to equal 7 times negative 11, because negative 22 divided by 2 is negative 11, and that equals negative 77. So the summation of all these numbers, if you got a calculator and went negative 2 plus negative 5 plus negative 8 plus negative 11 plus negative 14 all the way to negative 20, and then hit equal, you're going to get a total of negative 77. That's the summation right there. So since I'm doing the even ones on this one, let's jump to number 12. Look at that. This is the first time on this worksheet that we see the sigma notation. What the heck is this sigma notation? It's a fancy way of saying that you got to add up all your numbers of your series, but you don't even see your series. There is no list here, but you have to create your list from this function. This is kind of like your a sub nth rule, okay? The truth is you don't need to create your list. All you really need is to know how many numbers there are on the list. You also need to know your first number and your last number. Okay, so let's find out how many numbers there are on the list. Bless you. You would go 18, take away 1, plus 1. So how many numbers? Might as well write this down just so you could get comfortable. Go ahead and write down n equals the 18, take away 1, plus 1. I know that sounds ridiculous, but now we know that it's 18. N equals 18. That'll help you when you have an other number than 1. So if you have a 5, it'd be 18 take away 5 plus 1. That'll tell you how many numbers are in your series, all right? How about that first number? We're going to plug in the number 1 into here to find our first number. So plug in a 1, that's 3 times 1, that's 3, and 3 plus 10 is 13. So a sub 1 equals 13. Your first number is 13, okay? How about your last number, a sub n? Your last number is going to be simply plugging in that 18 right there. And of course, it'd be good to do it with a calculator to help you. 3 times 18, I'm doing it with the calculator, is 54, plus 10 is 64. So a sub n is 64. Okay, so now we have the 3 things that we need for the summation formula. We know our n is 18. We know our first term, that's 13. We know our last term, that's 64. We are ready to rock. So what we have here is the summation of these 18 numbers is going to be n, which is 18, times a fraction with a denominator of 2. And up on top, we're going to be adding the first number, which was a 13, with the last number, which was a 64. And 13 plus 64 is 77. So we really have 18 times 77 divided by 2. And you could, with the calculator, go 77 divided by 2 and then multiply by 18. Or you could divide 18 by 2 and then multiply. So it's up to you. 18 divided by 2 is 9. 9 times 77 with the calculator is 693. So the summation of the 18 numbers of this series that we don't even see is a total of 693. Jumping to number 14, that one's a little more exciting. Why? Because it doesn't start at 1, it starts at 5. Okay? So we're still using this same summation formula because the sigma notation, that's a summation. It's telling us to add up all of the numbers in the series that we don't even see here. But all we need to know is to know how many numbers there's going to be on the list, and what your first number is and what your last number is. So let's find all those 3 things. Let's start with the number. How do we find out the number? You're simply going to take the top number 12 minus the bottom number 5, but then you're going to add 1 to it. So 12 take away 5 is 7. 7 plus 1 is 8. So n equals 8. We now know what's going to go right here, right? Anyway, how about a sub 1? A sub 1 is going to be your first number. And normally we find a sub 1 by plugging in the number 1. But in this case, the first number will be plugging in the number 5. So when you plug in the number 5, it's 3 times 5, that's 15. 4 take away 15, that is negative 11. So I really have negative 11 as your first term. A sub n is technically plugging in that last input, 12, right there. So 3 times 12 is 36. 4 take away 36 is negative 32. So now we have the 3 things that we need to find the summation, right? And let's use the summation formula. So here's the summation formula. It's S sub n, S sub 8, equals 8 times the fraction over 2. And it's a sub 1, which is negative 11, plus the last number, a sub n, which is negative 32. So negative 32 and negative 11, that's negative 43. And it's still over 2. And you're still multiplying by 8. Okay. So you could do negative 43 divided by 2 on a calculator, then multiply by 8. Or you could simply say 8 divided by 2 is 4, and then multiply 4 times negative 43. That's what I'm doing right now on the calculator. 4 times negative 43 equals negative 172. So S sub 8 equals negative 172. So if I were to produce my series by plugging in the number 5, getting my first number, plugging in the number 6, getting my second number, plugging in the number 7, getting my third number, all the way to plugging in 12 to getting my last number, and then adding up all those numbers, my answer would be negative 172. Let's go number 16. 16 looks more interesting. So what do the instructions say right here? It says, find the first 3 terms of each arithmetic series. Okay, so they want the a sub 1, which they actually tell us is negative 3. They want a sub 2, which we don't know, and they want a sub 3, which we don't know. And this is a series, so technically, once you find all those, there's supposed to be plus signs between them, okay? But they just want the first three terms. We already have one, so we just need a sub 2 and a sub 3. So what do we really need here to find this next number? Anybody? To get from any a sub 1 to a sub 2, what do you need in an arithmetic sequence or series? Huh? Common difference, that's exactly right, common difference. So do we know the common difference? They don't give us a common difference. What do they give us? They give us a sub 1, which we already have jotted down right here. They give us a sub n. That technically means that if you kept going plus ... you're going to end up with the a sub nth term right here, a sub n, which we don't even know what a sub n is. Actually, we do. They give us a sub n. A sub n equals 41. So we could actually put that number right there, 41, for the a sub nth term. Okay, and they also give us the actual summation, which is 228. So they give us the s sub n. So what do they give us? They give us the a sub 1, which is right there. They give us the a sub n, which is right there. They don't give us n, but they do give us the actual summation s sub n right here. So we could actually plug in everything to find out n, okay? Let's do that because that's the only thing we can do right now, okay? So when I plug in parenthesis, fraction, we don't know n, just leave it as n, but up on top, a sub 1 is negative 3. You're going to add it with the last number, which happens to be 41. Okay, so you have negative 3 plus 41. That is a 38. So we really have, oh, and I forgot, let's plug in the s sub n value. S sub n is 228. That's what they give us. So we're going to put a 228 right here. Okay, so this is an equation that we could actually solve for n. Okay, so what is negative 3 plus 41? That's 38. So we end up with 38 divided by 2 in parentheses with the n right here equaling 228. So if you wanted to divide 38 by 2, that's, what is that, 19? So we really have 228 equals n times 19. But you don't want the n times 19, you just want n, so divide by 19 to get rid of the multiplication of 19. And with the calculator, 228 divided by 19 is 12. So we just found out that n equals 12. So how many numbers are on the list? There's 12 numbers on the list, okay? So let's reiterate the important information. We have a sub 1, we have a sub n, we now even have n, okay? But in order for us to find the next two terms, you need that common difference, d. And where do we see the common difference, d? We don't see it in this formula. We see it in the other a sub nth rule formula, which is a sub n equals a sub 1 plus parenthesis n minus 1 times that common difference d that we don't know. But if we know everything else, then we'll be able to solve for d. Now the question is, do we know a sub n? The answer is yes. They gave it to us. What is a sub n? 41. So we're going to put a 41 right there. Maybe I should do it in black. 41 right there equals, do we know a sub 1? Yes, it's negative 3. Plus n minus 1. Do we know n? What is n? N is 12. We just figured that out. So we have 12 minus 1, and we don't know d. But because we know everything else, we'll be able to solve for d. So let's just solve this equation using our Algebra 1 skills. 12 take away 1 is 11. So you still have the 11 times the d, and you still have the plus negative 3 out here in the front equals 41. Okay, so you want to get d by itself. Let's get rid of that negative 3 by adding 3. Adding 3, you're going to end up with a 44. 44 equals 11 times d. You don't want that multiplication of 11 in front of the d, so you're just going to divide by 11, and you will have the common difference being 4. So d equals 4, okay? What the heck are we trying to answer anyway? They're trying to answer what a sub 2 is and a sub 3 is. They want the first three terms of this series. So we went through all that work to find what d is, and now that we know d is positive 4, from here to get to this one, all you got to do is add 4 to it. So negative 3 plus 4 is 1, and 1 plus 4 is 5. So the instructions say, what are the first 3 terms of this series? That would simply be a negative 3, a 1, and a 5. Fun stuff. Yay? Okay. You know what? I'm going to stop right here. It's too long. But I think you now have the knowledge to do this whole thing.